Good morning, students. So this is the second video of lesson number 3, the nature of matter. So in the last video we came to know that everything is made up of matter, and we also discussed about the properties of matter, that matter has mass, okay, which we can see by the experiment of the inflated balloons, right? So in this experiment, what we have done, that we have put two balloons on a scale, and what happened? The similar balloons made the scale balanced. But if one balloon is bursted, then you can see the scale is slightly tilted up. So what it shows? That the matter has mass. We also learnt about the thing that matter occupies space. But what is this word space? See, it is the void between the particles of matter. Now let's understand both of these terms, mass and space. Another new term is there, that is called weight. See, this is a spring scale which weighs the weight of the empty and the filled can. But it doesn't shows you mass, it shows you weight. Then what is weight? And how is it different from this term mass? We'll learn in this video. We know that mass is the quantity of the substance, but when it is taken with gravity, it is termed as weight. Matter occupies space. So everything when we put around, it takes some space. That means the particles of matter, they move around the space in which we occupy. That is how when your mama opens up the packet of a liquid, it space inside the bottle and tries to fill the bottle up to the volume. See these two bottles. One bottle contains water filled up to a certain level and the another one is empty. That means this liquid is taking up some space, isn't it? Now see the beads in this container. These are also taking up some space. See, I have put some beads in my hand. If I keep them in empty bottle, they occupy space. That means matter in any form occupies space. Now let's make it more clear. What will happen if you see, if I add more beads, then the beads will take more space. You can see here. So that means matter takes space. This can be measured. Now let's see, you know that water is there at a certain level. What will happen if I add more matter into it? See, the level is rising. That means matter takes up space. Less matter will take lesser space and more matter will take more space. Can you see the level is rising? So if we continue to add the beads, the level rises up. That means the space will be taken by the beads also will be added to this level. See, it is very difficult to swim against a strong current, or we cannot walk easily during the storm or heavy rain. You can see here the glass blades also pushed by the storm. See here, the current of water is pushing the boats, and as a result the boats are moving. What it shows you? It shows that matter offers resistance. So it is also the property of matter that it offers resistance. Now let's see the general properties of three states of matter. But before that, we need to complete the take a break of page number 42. So let's see. everything in the universe is composed of matter. So first blank will be universe. Second, matter exists in both natural and man-made states. Third, mass is the measure of quantity of matter contained in a substance. Matter has mass and occupies space. Okay, so here we are continuously using the word mass, but I hope that you learn the difference between the terms mass and weight, and also you know what is the meaning of space. If you don't know, then space is the void between the two particles in a matter. If you will see here closely, you can see the void, the gap. This gap is called space. For your homework, you should answer these questions. What is space? I think you are able to write it in your own language. So please write it in your own language in your chemistry fair notebook. Second question, write the properties of matter. Third question, write the difference between mass and weight. So in the next video, we are going to learn about the different states of matter, the properties of the different states of matter, and the arrangement in solid, liquids and gases, the molecular arrangement, in the solid, liquid and gases, and about the intermolecular space and intermolecular force.